Alright, guys.
Oh, okay, we're here. We're here. We've made it through a whole year.
A whole year.
Of math class, guys. I cannot believe it. I've never done a whole year of math class in high school. I've only done semesters. Like, this has been a really, it's been about double the math this year, you know. It's 2 semesters, like double of one.
8th grade was the last time we did a full year of math, so yeah. This was tough. But you know what, guys? We made it through, and tomorrow's
the big day, guys.
Is the Calculus AB AP exam day.
Yep. Not the Calculus AB exam, but it's the Calculus AB AP exam.
Yeah.
I think that's what I said.
That's the key difference.
Yeah. Okay. So we're out here grinding. You know, we're trying to motivate you guys. You know, all you other calculus students that are watching this video around the world. This is for you, and this is also
we're doing it for you.
If you're not a calculus student, this video is also for you because you know we welcome all sorts of viewers on our channel. You know, you can be.
We don't discriminate.
You can be a dog. You can be. You can be
a
Pacific
cat.
Islander. Sorry, you can be Alaska Native. It's all right.
There you go. Everybody's welcome. Okay. So,
Eskimos too. All right, so we're gonna be just going over all of our topics and like we're trying to motivate you guys on each topic. Like some stuff may seem more difficult, you know. I've got my Barron's review book here. If you guys haven't seen one of these before, it's like according to this, it's the leader in test preparation. Students' #1 choice. So yeah, this is my #1 choice. I've been using.
It is the #1 choice of all calculus students. So you guys should definitely pick up this book and work your tails off doing the entire thing, because that's what's going to get you a 5, guys.
I mean, that's the goal.
Barron's
5.
AP Calculus.
You know,
I mean, look at this guy. This guy looks prepared, and you want to be this guy.
Yeah, this guy, I mean, I'm pretty sure this guy made a 5. As you can see by his finger, he really... Ugh. If you can't see that, he's actually using his middle finger there, guys.
Yeah.
He really appreciates math.
He feels quite strongly.
He probably made a 5, and our motto in calculus that our table in class has developed lately, it's 1 or 5.
It's either 1 or 5.
I mean, there's no in between.
We determined that if we don't get a 5, we're going to get a 1, and if we're not going to get a 1, we're definitely going to get a 5.
Yeah, I mean, it's either pass or fail. I mean, I took the class pass fail, so. Yeah.
But for those of us that didn't, it's really all on the line.
Most of you guys you don't pass fail AP classes because you really care about your GPA, but GPA is just a number. Like, it doesn't define you.
No, GPA is just.
Am I a number? No, I'm a human being.
Remember that, guys. You are human beings. You're more than your grade.
That's true. Grades don't matter.
Tomorrow you are your grade because you're taking the AP AB Calculus exam.
Very true. 1 or 5. You're gonna
1 or 5.
You're gonna be one or the other tomorrow.
Are you a winner or a loser? And we want everyone watching this to be winners.
If you're not first, you're last, guys.
If you're not first, you're last.
So
Ricky Bobby.
There's only going to be 1 5 out of the whole entire country.
Yep. No.
That's first.
You guys want to be 5. Remember that.
Yeah, really
that's tip 1.
Okay. So we're going to be going over all the calculus units in. It's going to be pretty brief though, because you know we don't want to make this video drag on. Yeah. Okay. So the first unit in the Barron's book is functions.
Functions, guys.
I'm going to define the function. A function f is a correspondence. Ooh, okay. Big word. It's all right. That associates with each element A of a set called the domain, one and only element B of a set called the range. We write f of A equals B to indicate that B is the value of f at A. The elements in the domain are called inputs, and those in the range are called outputs. Okay. So if you guys haven't ever learned what a function is, that's what it is.
Oh yeah.
If you
should probably know a function before what a function is before you take calculus AP.
Yeah. Honestly, if you don't know what a function is at this point, you're likely to make a 1, but it's okay. It's okay.
Because it's either a 1 or a 5.
It's still possible. I didn't say you're guaranteed. I said likely. Okay. All right. Functions. You know, if you don't know those,
you just got to know how to graph.
Yeah, graph by hand, really good strat.
Graph by hand.
On the no calculator section.
When you don't know, you just need to throw out a guess. Just graph by hand, guys.
Okay. And the next definition. Do you want to read this one? We're on the limits.
Right, we're up to limits. Okay, and the definition of a limit is the number L is the limit of a function f of x as x approaches c. As the value of x gets arbitrarily close, but not equal to c, the value of f of x approaches or equals L. We write, and then if you guys want to see it right here,
if you guys are visual
this
learners,
is the limit form. You know, you got to remember that. That's quite important. I don't even really know if I'm on camera right now, but I think you guys get the drift because you're AP students. You know this and you got this.
Yeah, okay, keyword in there, guys, is approaches. Limits we're referring to where it approaches.
It's where it's going.
Yeah.
Remember that, guys. You got it from the left side to the right side, negative or positive. If it's going to infinity, got to know all your limits, guys, because that's going to be key. Remember L'Hopital's rule.
L'Hopital's rule.
L'Hopital, there you go, folks.
L'Hopital, he's a French mathematician, you know.
You know, if
he's one of my
you've
favorite
got
mathematicians.
the thing where you can't, where either the top and the bottom of the limit, if you take it, it goes to 0 or undefined. You gotta take the derivative of the top and bottom, which you know we'll be going over derivatives later, folks. You should know that.
By later, I think we mean right now, because
all right, we're skipping right to derivatives, folks.
The next chapter in the book is differentiation.
It's as if this read my mind.
And if you guys don't know what differentiation is, that's actually derivativization.
Derivativization.
Okay, so definition of a derivative. All right, this is going to be really complex, guys. I'm going to read it out symbol for symbol on here. Okay. At any x in the domain of the function y equals f of x, the derivative is defined as lim as delta x goes to 0 of f of the sum of x and delta x minus f of x, all divided by the delta x, or change of y over change of x.
Now,
you guys get that? Oh, what's up?
I think we might have cracked it, Clark.
What do we do?
Wait a minute. Delta y over delta x.
Oh my gosh. Wait.
Could it possibly be, folks? Could this be what dy dx is?
Oh my god. Did we really?
dy dx is just a derivative.
I cannot believe we found this out while recording this video all year.
Guys, this was live.
Oh my gosh. The day before the AP exam, what are the odds? It's such a coincidence.
We understand now. This is 5. This is 5 territory stuff right here, folks.
Luke is such a
dy dx
such a creeper.
is really just the derivative of a function. Alright, yeah.
Okay. Yeah, derivatives, you take them. Alright, we're going to teach you guys some derivative rules. Alright, under this next section of the book, we have the formulas, which there are many.
There are a multitude. And many. Plus 1.
Okay, so pretty much all you guys got to know is the power rule, the product rule, and the quotient rule. Okay, the power rule, you know?
What about that chain rule, though, Clark? Chain rule's next.
Chain rule's next. Okay. Power rule, you know, you bring down the exponent
into the front,
and you just minus 1 from it. It's pretty easy, guys.
So basically, like, here's an example for you guys. If you were taking the derivative of a function x cubed, and you know the derivative is just the slope of a function at any point, what you would do is you take the cube, the 3, the exponent, and bring it down in front as a coefficient on the variable, and subtract 1 from the exponent, so it'd be 3x squared. That would be your derivative.
That would be. Okay. Other formulas, you know, you got to know your trig formulas, your ln, your e. That's pretty simple, guys. All you got to do is remember it.
Just remember your trig formulas, remember your trig identities, and you'll be completely fine.
Yep. Got to remember those half angle formulas, just a prank. Okay. The chain rule, my favorite rule. Okay, I've been stressing this all year. The chain rule, you can just use it. You can use it on any
function.
You can, like, if you want to take the derivative of 1, you can use the chain rule.
Yeah, you can.
Because, you know, 1 is technically being raised to the first power at all times. So, you know, all you got to do is do a u to the 1 substitution, and it becomes just a constant. You know, 1 to the 1. You know.
Chain rule.
1 to the 1 is 1. Yeah, chain rule. Okay, so you know the chain rule. Just pretty much
it's
simplistic form. It's the derivative of the outside times the derivative of the inside. Pretty simple.
Yeah, so if you have like some kind of thing like 2x plus 1 to the 3rd power, it's the derivative of the inside, which would be 2x plus 1 times the derivative of the outside, which would be the initial thing, u, to the 3rd power. And then you just take the derivative of both and multiply them together.
Yeah, a lot of people have complained about the chain rule all year, but honestly, it's not hard. You guys.
It's not hard.
It's a really easy rule. If you guys don't know the chain rule, you're probably going to get a 1.
But
just one of those things.
You're aiming for that 5, so know the chain rule.
Yeah, know the chain rule. All right, we're moving on to the next chapter.
We're moving on, folks.
We're still on differentiation here. We've got some practice problems. Wow, there's a lot of differentiation.
Wow.
Actually, I should probably learn that stuff.
Differentiation of an inverse.
Yeah.
We
implicit differentiation.
implicit differentiation. That's quite important because dy dx is also used there.
Derivatives of parametrically defined functions.
That's some BC level stuff, folks. So don't worry about that.
We've got the MVT here.
Oh, the mean value theorem.
One of the most important ones, along with Rolle's theorem. They're pretty similar.
We've
Use those
gone
for
over
your free
this.
responses, guys. Use
Yeah,
those
guys.
in your explanations.
Remember to use it.
Otherwise, you're going to get 0 out of 9s.
No, you don't want a 0 out of 9s. It's either 0 out of 9s or 9 out of 9s, and you're gonna get 9s.
Yeah.
Do it.
Optimally, you want to get 9 out of 9s on 5 of them, and just 1 0 out of 9. That'll be a.
That's the only
that'll
0
be a
out of
good
9 that you
score
can
for
accept.
You can only get 1 0 out of 9, or else you're just going to make a 1. There's a lot of risks here, guys. Ones are imminent, but
You know,
we're making 5s here.
we're making 5s here.
Oh, okay. The L'Hopital's rule. Okay. Derivative of the top, over derivative of the bottom. If you want to, if you want to find a limit of the indeterminate functions, like, when the denominator is equal to 0 or infinity, something like that. L'Hopital will help you out.
We gotta be here, folks. But you know what? We want to get 5, so we're staying right here.
Where's the B at? Oh! I'm good.
Oh man, we're good, folks.
Something touched me.
See, we do anything for you guys, because calculus, it's the most important exam we're taking right now.
Yeah. Big
So,
day tomorrow. Biggest
We're
day
doing
of
it
my
for
life.
you, and it's the biggest day of our lives, so be ready for it.
Okay, just making sure. The video's going to end in like 5 minutes. You heard nothing, folks. Okay.
So we're gonna keep going.
We gotta speed up the process here, guys.
We're speeding up. We're going really fast.
Okay, the answer to number 1 on tomorrow's exam is actually E. I have the answer key right here, guys. There you go. If you want to screenshot that right now, you get a 5.
All right. Let's keep going. Let's hit the
Oh,
major
gosh.
topics.
Okay. Applications of differentiation.
No. They know how to
Apps
apply
and
a
derivatives,
derivative,
okay.
Clark.
Critical points, you guys know. Set
You
the
guys
derivative
know.
equal to 0. Simple. Increasing and decreasing derivative where
You
it's
guys
positive
know.
and negative. Easy. Concavity minimum.
That's just the second derivative,
second
guys.
derivative.
You know that.
It's simple. Okay. We're zooming here.
We're zooming.
We're trying to get through as many concepts as we can in a limited amount of time. This is a lengthy chapter. Oh, okay. We're on to a new concept here. Anti-differentiation. Much different than differentiation.
AKA
As you can tell,
anti-derivative.
right? Yeah, derivative. You gotta make sure it's spelled right. Okay, an anti-derivative. You wanna read the definition?
Okay, this is quite a lengthy definition, so you should really pay attention to this.
Okay.
The antiderivative, or indefinite integral of a function, f of x, is a function, big F of x, whose derivative is little f of x. Since the derivative of a constant equals 0, the antiderivative of f of x is not unique. That is, big F of x is an integral of little f of x. Then, so big F of x plus c, where c is any constant. The arbitrary constant c is called the constant of integration. The indefinite integral of f of x is written as, alright, you guys gotta do this, because it's like, yeah, look at this, it's like this weird looking S type thing, and f of x, and you gotta remember to put on the dx in the end, because otherwise you're gonna get points taken off, folks, because that's key.
I think that F thing stands for theta. Is that right? Theta?
You heard it here first, folks.
Alright, yeah. We're gonna call that theta.
I learned something new.
Because it starts with F and that's an F, obviously.
Obviously enough.
Okay, antiderivatives. So an antiderivative is pretty much the opposite of a derivative. You just have to
Instead of lowering a power, you're raising it to it.
You have to understand
you're raising
the patterns.
it plus 1 power.
Multiply it by the reciprocal to cancel out.
So,
yeah, guys, you probably know what that means.
You guys should know what it means. It's not a very difficult concept. Once you've gotten down the whole derivative concept, you can pretty easily transfer your knowledge into antiderivatives.
Another important thing to know is that the antiderivative of a cosecant is actually the ln of a cosecant minus a cotangent. Heck off, B. Ah! Ah!
Oh man,
ah!
be on camera.
Ah! Get away from me, seriously. B!
The bee is attacking us, folks. We're alive.
Ah!
We are alive.
Yeah, get out of
The
here.
video's going.
Okay, I don't think the bee likes cosecants. Anyway,
No.
so we're gonna move on past that. There's the hecking bee.
The hecking bee, guys.
You got to know the tic-tac-toe method right here, guys. Actually, no,
We've never used that, so I don't know.
Well, I'm retarded.
If you know what it is, then
you're
put that in the chat.
You're ahead of the game. Can I get a 5? Differential equations. That's a it's a later unit. I don't know why it's being discussed right now. Okay, we got 3 minutes, guys. Definite integrals. Okay, pretty much the same thing. You know,
you're putting it between 2 points and plugging in each point.
Okay.
Top minus bottom.
Another key theorem in calculus is the fundamental theorem of calculus. It's where
you go, folks.
Okay, so let me just read it out. So the integral, or the theta, excuse me, from b to a, actually from a to b, of f of x dx equals big F of b minus big F of a. You know, definite integrals. You should know how to do those. They're pretty simple. We're moving on. Okay, apps of integration to geometry. Ooh, do we want to go over this?
You know, it might be necessary.
Okay, I think it is necessary. This is a difficult concept to learn right here.
Area and volume. Only this time, it's with curves.
Okay, so pretty much with area, you're like
taking the integral of a function.
Yeah.
And it's top minus bottom and left minus right. And then but that's for area, and if it's volume, you need to square those functions and multiply by pi out front.
You do.
Basically that simple, folks.
You find the R, big R, small r, from what I remember. Could be wrong.
Big R and small r. Now we know.
Probably going to be a free response question that I will miss tomorrow.
No, guys.
It's going to be my 1-0.
That's going to be his 1-0 out of 9. But if you guys know it, you're fine. You're going to get a 5 easy.
Okay, volumes. You know, with cross sections, you know, you have to
find the area of whatever the cross section you're doing. So if it's a square, it's s squared, and you know, you take the volume given that area, you know.
Pretty simple.
Basically, it's it.
You've been practicing that for the whole year.
Yeah.
Solids of revolution, you know, revolving around an axis. That's just that's, again, the squared with the pi up front. Pretty sure. I could be wrong.
Oh yeah.
We have the washer method. Oh, that's big R, small r I was referring to earlier.
Yep. Big R squared minus small r squared. Pi out front. Traffic.
Oh gosh. Gotta go fast.
Oh yeah. We going.
Okay.
Oh man, he's looking.
Less than a minute. Okay.
Less than a minute. We need to wrap up this bit, guys. So.
Okay. Further apps.
Further apps.
Don't even know what's on here. Oh, this is area, volume.
Just.
Area.
You guys
velocity.
know everything.
Excuse me. Acceleration, velocity, position. You know. PVA.
PVA, guys. Remember that.
Traffic. Okay.
Okay,
we're on the last one. Diffie Qs. Okay, Diffie Qs are
basically.
You gotta what do you call it?
When you got you know, x and y, and a dy dx in an equation, you know.
When you find the general solution, you got to use C. And
this video about over. Maybe it is.
Oh yeah, we'll see you guys in the next video.
Yeah, we appreciate you, fans. Alright folks, this is some bonus footage.
Take the area. What's the equation?
Alright, the equation is, that's side S. That's side S, and I want to minimize the area.
Okay, how are you going to do that?
Minimization, so you know what I'm going to do? I'm going to
optimization.
Find the, an optimization we didn't talk about that, so this is a good learning technique. You know, you just sort of, you find the two, you know, functions you're gonna optimize, maximize, minimize. You know what I'm talking about.
Yeah.
And then you multiply them together. And, you know, you just take the derivative of that.
Yep.
Set where it equals 0, and that's your points of maximization and minimization.
There you go.
Remember that, folks.
Key point.